Yeah, hello everyone. Good afternoon. So I hope we're not too tired right now, so we're still energized to survive the session. So today you see only two of us. All the work we are presenting is of course teamwork, so there's a broader team behind that. And yeah, can we, how does it work? I'm not familiar with this kind of technique. Next. Okay, good. So you see that we have a very strong background for our digitalization initiative. So our CIO is behind that, and he's actually saying that digitalization for our company is as important as biology, chemistry, lab work, discovery research. So actually we're doing a lot of research ourselves. So Merck is a leading science and technology company, so most of you may know us from chemistry or healthcare framework, but this is not the only place we are producing things. So we are in healthcare, we are in life sciences, and we are in performance materials, so that's a really broad portfolio. And what's remarkable about this slide is not only that we need to show our company a little bit, we have around the world over 50,000 employees. We're active in more or less 66 countries. And so you can see that we have a lot of data around, and they're certainly not all live in one database, and they're not easily accessible. And yeah, so what's our vision? So what our team basically wants is unlock the hidden value in data. So that's kind of our mission statement. And so the mission is that we derive value for our business and our customers. So a lot of customers live in B2B, but of course we have also other customers, like for instance, I mean, it's not a nice comparison, but I would say patient is a customer taking our drugs. So that's true as well. And of course we want to discover all these hidden values in our data, and we want to aggregate them, and we want to create new insights to help our business to make better products for you. And yeah, so one part, what we are doing and what we're a lot behind is informed decision making. So that's not like dashboarding, like traffic light schemes. It's really providing some useful information to take decisions upon. It's predictive analysis, prescriptive analysis, anything which has to do with that. And yeah, we're trying to establish a data-driven culture to support our R&D space. We are providing, of course, core capabilities. So our team is pretty young, so we exist since approximately 2.5 years. So right now we are around 15 people, plus a lot of bunch externals. And what we've done in this time is we set up an enterprise platform. We are providing a lot of governance. We are owning this big data technology, and we do have analytics tools and competencies. So that's why Florence is here. He will talk you through some good examples to that. Yeah, and then we are growing our internal expertise, so we're interested, of course, to internalize all this knowledge and have good people around us driving our mission forward. And yeah, one of the important things is data democratization and visibility, of course. So what have we set up in the past years? So there is, let's say, some core technology, which is our data lake, and it's used to ingest data from any sources. Yes, it can be on-premise, it could be cloud platforms, any internal, external sources that exist. And we are focusing on people, process, competency, and data, because one could not live with the other. Yeah, so it's all equally important, I would say. And yeah, so for instance, so we've been also through a lot of audits and assessments, so we managed to get our platform GXP validated so that we can even go in this submissions for a European medical agency, which is now having some new ISO standards in place, which is called IDMP. And we are providing analytics and insights to do this informed decision making, and we're using some base technologies, just a few of them: Hadoop, Spark, Hive, R, Python. So that's our standard tool sets. Yeah, so here's a little bit more high-level architecture slide. So as you can see, we can ingest any source in there. So it's a lot of questions are, of course, around SAP systems. Some are relational databases, messengers, streams, web, and other. And we have different technologies to pull the data in. And our core technology is HDFS system, so Hadoop file system, and we're doing in-memory processing. That's why we use Spark. Then we have a SQL engine, Hive, which we also need to transfer the data over to other things. We have Hive tables and anything in the underlying architecture. And then we have an index store where we're doing Elasticsearch, and we have some other tools to help us with data lineage and all the stuff. What's important to us is setting up the data catalog, because you can imagine as we're taking data out of any of these sources, it can become pretty much a mess, and we don't want to end up with a data swamp. So that's why we are putting a lot of metadata behind there. We store them, we retrieve them, we can process the data with all these backend information, with all these tags. We have very strong security and permission layers, and of course a lot of management tools for this environment. And yes, and ultimately what our customers are going to see is some nice search tools where they can search for sort of data, for a data set, for a feature, and then hopefully it will show up and they can say, oh, I'm interested in that, can I buy it, can I have it from you? And yes, and that's how we're producing our data products. And we have the analytics part where you run some algorithms and you come up with some prediction or with machine learning or AI. And then normally what the business does not want to have is a huge list of code or any Excel-like output. They want to have a nice visualization, and here we're using some standard visualization tools which we buy in. So yeah, that's something I need to maybe re-emphasize, that strong information governance is needed for all that. So as we take the data from internal and external, we do have a very performant computing platform which is built on a big data stack. We have our analytics tool set, and of course we need to take care of sustainability, which is catalog, search, visualization, containerized, scale, deploy, all these sort of things. And then we have processes in place, and this is maybe one of the hardest parts that you can do in a company, to set up a lot of process. So you have to, normally I don't own any data, so I have to go to my business partner and ask them, you want me to provide this analysis, so how can I access this data? Do you allow me to take the data in the data lake? And so there's a lot of rule sets and policies in place to make it happen. Yeah. And then what our engineer team is normally doing, so they're enabling to take the data out of any source and ingest it into the lake, and then there's some gathering, cleaning, combining, messaging the data, so that you get your data set ready for analytics. And yeah, and from a compliance point of view, we have, of course, take the data fit for purpose. We cannot just say, oh, we want all data out of Merck. That won't work. So we have fit for purpose, and we have to really fill in some forms to make it happen. And then due diligence is one important thing, so that we commit to, let's say, to some legal aspects we have to follow, of course. GDPR, everybody knows it now. And data lineage, you have to track your data end to end. Where is it coming from? What has happened to the data? Where do you provide it to? Governance and security, just mention it in general. And I mean, important is the people. First of all, the people who are behind it and working with the data, but then also the consumer. Yeah, and this is normally digital or business leads, business analysts, other data scientists. So we want to provide our tools on a broader scale, like self-service analytics, and yeah, developers partnering, whatever. Yeah, so now it's your turn, Florence.
Thank you. So as Claudia explained, Merck is a large company, a diverse company with many different business sectors. And in that large company, we are one, by comparison, small team that aims to serve the entire company. And as such, of course, that brings with it some challenges, but also quite a bit of variety. And so here we just want to pick out a couple of examples of things that we have done so far to specifically implement some solutions. And one thing that I heard earlier today in one of the talks that really struck a chord with me was there's somebody said that you need to balance investments into long-term infrastructure and the capabilities that we want to build, but then also have some use cases, some quick wins where you can show people and say, this is something that is possible, that maybe you tried before, maybe you thought about before, but you didn't have it, and now you do. And so in order to get buy-in from the organization and also to spark some ideas of what might be possible next. And so in that, this is kind of the idea why we sort of picked some examples here as well to say these are some things that we have done based on the platform that Claudia now explained. And so the first one is on a project for end-to-end visibility on Merck's supply chain. And so the idea is to really know which raw product is transformed how and ends up where. And so in principle, maybe that sounds like an easy question, maybe also sounds like a question that every business should always know and maybe always has known. But in the case of Merck, it's not that straightforward because, first of all, Merck has grown over the past 10 years, as many other companies, I guess, as well, through some large acquisitions. So then maybe within the now subsidiaries, you may have that visibility, but you may not know what happens if these subsidiaries interact with each other. That's one challenge. Another challenge is the variety of the product catalog. So in life science, we have about 300,000 distinct products. Performance materials, many of the products are almost like custom made for some of the larger customers. And then there's healthcare as well. Then there is healthcare that buys products from life sciences and takes that as input. And so this can get very confusing quite quickly. And then you take into account that you have many different data sources, partly due to the acquisitions, partly because of things that have just organically grown over time. And then the problem becomes somewhat complex. And so in this particular use case, what we then did was to aggregate the data from these different sources in the first step. And this is not particularly data sciencey. This is not particularly advanced maybe, but it was really a crucial step and already improvement to just have it in one place. And this is actually also a process that continues to go on to get more and more sources in there. And so maybe you've experienced something similar in your companies as well. So we took it into one place, and then you sort of have the data from all the different systems, but you still don't necessarily directly know how the products flow over time, because again, this can be quite complex. So you have a bunch of raw materials in the beginning that are then combined somehow to have intermediate products maybe, and then in the next step, they're again combined to another intermediate product that is combined with some raw materials, some other intermediate materials, and then finally you get something out at the end. And so what this creates is a potentially quite intricate network of products. And so what we used at this step, and this is where it becomes a little bit more like data science, is to construct a graph database out of this information so that we can really see the interaction between the different products. For those that are interested and implement these steps things themselves, we use the iGraph package in R. So we were fortunate enough that despite the fact that it's reasonably large data, it still fit into one node. If this gets even larger, then we probably should think about something that's more distributed. But for now, iGraph did just fine. But through this, we then could really see the entire chain from the raw product to the finished product through, and also all the interrelationships between the different products. And this was so the first concrete use. So I mean, it's nice to know, but what do we actually do with it? The first concrete use for this was to manage our risks with regards to suppliers. But so particular, there were some products that were derived from animals, and there it's important to understand which final products do these animal-derived products go into, so that we can then see which of our suppliers, I mean, particularly important, where we need to take extra care that these suppliers really conform to our guidelines, for example, that they treat animals in a sustainable and acceptable manner. And so that's a reputational risk. But going forward, we can, of course, do many more things with that. So, for example, you can look which are the suppliers that have the largest impact on important final products. Previously, we could only see which are, for example, the suppliers that we purchase a lot of raw materials from. That's fine. But do these then go into high-margin products? So it's really important that we always have something on stock, or in maybe some products that are less important. And so this is one example of where we want to go next with this. Another of those, or the second of two, concrete examples that I wanted to mention is on sales forecasting. So again, I think this is something that it's quite likely that you may have encountered this as well in your companies. I think it's a request that comes up very frequently. I want to know what I'm going to sell going forward. And so in this particular case, this was as part of the business in China for Merck in the healthcare sector. They have a bunch of different products they sell there. And they want to forecast the sales. And they have been doing this for years now. I mean, sales forecasting as such isn't anything new. The way they did it was with an expert panel. So a relatively large group of people would meet once a month for, I think, a day, sit together in a workshop and come up with these forecasts. And I mean, the performance of the forecast wasn't actually that bad, because here you would have people that have spent maybe half their lives selling pharmaceuticals in China, and so they have a pretty good idea of where the sales will come up. But of course, it's quite time intensive. Also, you take very skilled people and you put them into a room in order to come up with some numbers for this forecast, and so this is maybe not the most efficient way, and maybe we can also improve on accuracy a bit if we do this automatically. And so here then we gather data on past sales at first, but then also some data around that, so it wasn't just pure time series data, but also information on some other aspects of the healthcare market in China, and fit this into a number of different machine learning models. So we started with, again, for those that implement these things, the good old friend AutoArima in R, but then also went on to some other models like gradient boosting machines, etc. And with that, we were able to, well, first automatically create a forecast with the click of a button, as opposed to sticking people into a room. So that was a big win. And then as well, we were able to increase the forecasting accuracy, in this case by 2 to 4 percentage points. So before, for let's say the average product, they were like at 85% accuracy, now they're at 89. Is that enormous? I don't know. As I said, they didn't do so poorly before, but at least now you really can have the people spend their time in a more valuable fashion, because this part of their job is now it works this way. And so these are two examples of the type of things that we did, as I said, to show people what can be done, to show the organization that they don't have to wait for 4 years until we have fully built up the infrastructure to get results. And we've done this in a sort of analytics as a service fashion. So the business had the questions, the business units, they had the domain knowledge, and we had the knowledge on the platform and the technology on how to implement, then we did this together. And I guess that has quite some advantages, because for us, we work with the platform on a daily basis, so we know it quite well. But it also has, I think, some disadvantages, in the sense that while we know the technology and the business knows the business and the problem, bringing this together is not always easy, because the people with the ideas are not generally the people that have access to the technology, so they can't try them out. They have to go through some kind of review process to get to us, and then to get us to do this for them. And by that time, you've already lost quite a bit of time, and it's a bit cumbersome for people, of course. So some good ideas may well be lost. And at the same time, what we've observed is that throughout the organization, more and more people are being part of the business with the necessary skills to also implement, at least to some extent, machine learning, data science techniques themselves. So they then can just try out something very quickly. And this is sort of where we want to go next. We have these use cases that we can do ourselves. We have analytics as a service. Let's support the organization to do analytics as a self-service, and to bring the analytics closer to the users and to the business itself. And so to that end, we have started to establish what we call the Merck Data Science Toolkit, which consists of different components. The first component of this is a machine learning suite that has as a goal to make machine learning simple, or at least simpler. I mean, I don't want to completely make my job obsolete, so let's say simpler. And the way you want to do this, we want to by providing a common framework of operations that typically arise. And the way that we think we can make this useful for people is, A, it should be really simple to use. The barriers to entry to using this shouldn't be too high. But then at the same time should be modular and flexible, so that as people, they start out with this, maybe let's say some function that creates a machine learning model for them and evaluates it and all that, does all of this on the fly, basically. But then as the users become more mature, they probably want to start tweaking it further, and it should also support that. And so the way that we have started to do this is to create packages in R and Python that encapsulate certain pieces of functionality that are then made available to users in the business as part of the data science toolkit. And more specifically, we want to put this on Docker containers so that we can give the people within the container quite a bit of flexibility without having to give everybody admin rights on our server. So within the Docker container, they are quite free in what they want to do. Outside of it, we have the control. And then the idea is that indeed these different business questions flow in. The analyst on that side can go through this, let's say, typical cycle and develop something. And as part of that, they may see it's not a good idea. And that's fine. Then they experiment and they can go on to the next idea. They may also find this is a fantastic idea and I want to have this run every day, but I don't know how. That's also fine. Then they can come to us and we will help them set this up in a productive manner. Or they find, well, I tried this. I think it's a fantastic idea. It doesn't work. Can you please help me? That's also fine. Then we can help them there as well. But this, at least we think this will get us closer to the business here. And this is just one example. So something we did to show you like how much easier this type of framework can make it. So for one project that I implemented earlier, we created code to fit different machine learning models, to evaluate them, to explain them, like these are the most important features that go into this. This is how well it does. These are some hyperparameters that are associated with this, and so on and so forth. And this took me, I think, like several weeks and 500 lines of code to do. Yeah, with the help of this encapsulating functions, you could cut it down to 5. And so this is kind of what we want to achieve, not for ourselves, and then also for the business. And with that, we're at the end of our talk. Thanks a lot for attending and for listening to us. And yeah, happy to take some questions, I think. Yeah. Thank you.
Yeah.